Okay, so hello everybody. So my goal today is to give a brief overview of the optical metasurfaces industry. So I'm part of Yole Group. So Yole Group is a market intelligence company mostly who provides market intelligence and teardown analysis for the semiconductor industry. So basically, these are our main two activities: market intelligence, teardown, and reverse costing. Most of the information that I relate in this presentation come from two reports that we wrote last year, Optical Metasurfaces 2024 and Displays and Optics for X-Reality 2024. Okay, so here is a simplified definition and applications of the metasurfaces that we consider in Yole. So basically, we consider that metasurface component is a diffractive optical element, which critical pattern size of the diffractive structure is in the range of the operating wavelengths. So basically, two categories of components. On one hand, the gratings, binary slanted blazed, and let's say this kind of nanopillar-based diffractive optics. So these gratings, we'll find them mainly in augmented reality glasses, or there are some concepts related to 3D naked eye display. And this nanopillar-based diffractive optics mostly in the world of imaging in a 3D sensing module as well as camera modules. Okay, so here is an overview for the display. So in the blue bubble, you have the representation of the optical functionality that is achieved by such components. So basically for the augmented reality, what we look for is the optical coupling. So bringing the light from the free space to a waveguide and outcoupling the light from the waveguide to the free space. So here is the goal of that is to bring the light from the micro display engine to the user's eye. So this is the case. Most of the AR glasses that are presented at the moment use this kind of diffractive gratings. This is the case, for example, of the Orion Meta prototype, which is based on silicon carbide waveguide and gratings. The other applications where we can find this type of structure could be what we call the 3D naked eye display. It's mostly related to the activity of Leia, so it's a company who works in the display activity. So the goal here is to integrate micro optics in front of the pixels to enable 3D imaging without wearing any glasses or any devices. So here there are two approaches, a refractive one or a diffractive one. So the diffractive approach is a long-term perspective, but still enable interesting things like 2D and 3D switching mode. For the imaging world, so basically the metasurfaces can be considered as a standalone component into the camera module to replicate what does a standard refractive lens. So basically the focus or the collimation. It can also replace more traditional diffractive optics by doing what we call a pattern projection. This is what is used in biometry module, for example. So in that case, the metasurface allows for size reduction of the camera module by removing several optical elements by one single metasurface, replacing them by one single metasurface. So the main goal is to reduce the size of the module as well as the cost. Here is a brief timeline of what we observed linked to this type of metasurface. So we saw them for the first time in 2023 into this module from STMicroelectronics in this smartphone. So it was at the rear side of the smartphone in what we call a DTOF multi-zone array for range detection. In 2024, we saw for the first time this type of metasurfaces going into the Face ID illuminator module of the iPad Pro M4. Now we expect this type of metasurface also to be integrated in the same way as in the iPad, but for smartphones biometrics. And so until now, we see most of these metasurfaces operate at single wavelengths for near-infrared imaging, and before seeing them operating in RGB for color imaging, so where we can find most of the volumes of camera modules, we should probably wait longer because there are still some technical challenges to solve. And I'm glad we have a presentation about this topic later. So here is what we found in this in our laboratory in Yole Group. So we do the teardown of the modules. So here, basically, on the left-hand side, you have a comparison of the structure of the Face ID module found in the iPhone 14 that didn't use the metasurface. So we see we have three refractive lenses on the illuminator, plus what we call a DOE, so a diffractive optical element. And you see that the diffractive optical element is made of two substrates with linear patterns here that make the diffraction, and at the end allows for a dot pattern projection onto the user's face. And now in the iPad Face ID module, the last one. So here there is a cross section of the module. You see that in front of the illuminator there is only one single element, and actually when we perform SEM image, we see that it's a nanopillar shape element, so a metasurface. So we'll do a report comparing the structures of this module in terms of pure architecture and cost, so stay tuned to our activity. The other concept where we can find metasurfaces is when we use them as a deflector. So it can be used as a spectral deflector or as a polarization deflector. In that case, the metasurface is directly integrated onto the pixels of an image sensor, for example. So it replaces the micro lenses, or it can be complementary. And the main goal, the main added value of such concepts is to increase the signal to noise ratio that is collected by at the pixel level. So here, for example, there is Samsung that works on what they call the color router to increase the signal to noise ratio in RGB image sensors. There is also this startup AO that has been spun out few times ago, also working on a kind of color routing like this. And there is Metalensi that released a concept of polarization sorting. So it's something similar but related to the polarization state. And here the goal is to enable biometrics, not doing 3D but polarization sensing. Okay, so here is a brief quantification. So basically, the goal of our report last year was to try to understand where the metasurface could fit, with what application, and what could be the market associated to the business of metasurfaces. So we counted in 2023, the market could have represented $62 million and could go towards $2 billion in 2029. And you see that when we analyze the split between imaging and display, most of the part of this value is in the AR field, so the display side. So the business opportunity is significant, but this is pretty uncertain because it's totally linked to the emergence of the AR market. For the imaging, it's so the business opportunity might look smaller. However, we are pretty sure that metasurfaces will eventually penetrate at least the near-infrared imaging modality. So we are pretty confident that this scenario will eventually occur. Here is a brief overview of the different design, manufacturing, or materials that can be used for the manufacturing of the metasurfaces. So basically, at the display side, so we have so what we'll use in the AR eyepieces will be the gratings. So the gratings have a relatively uniform shape over their size. Let's say the critical pattern size is not so small compared to the imaging the imaging optical functionalities. And also the refractive index can be smaller compared to what we need in the imaging field. So the candidate, let's say the process that is anticipated to serve the AR market is based on what we call the nano imprint lithography. So this consists in, for example, we can imagine we have a substrate, we deposit high refractive index polymer resist, and we directly imprint the structures with a stamp on it. For the imaging side, so the design is much more complex. The refractive index needs to be higher. So currently, what has been spotted in our teardown, let's say, is mostly using a standard semiconductor process, so silicon and silicon dioxide process. So this is suitable for the near-infrared wavelengths, but if we want to move to the RGB domain, so the visible one, we'll probably need to find new solutions based on glass substrates and titanium dioxide, for example, with additional challenges also linked to the process engineering. Here is a brief overview of the supply chain, how it's structured, let's say. So here is a representation of the supply chain. And in the green area, this is where we find most of the startups. So most of the startups are focusing on, so there are some that focus on the, let's say, They are fabless designers, so they bring the technology from the knowledge in the laboratory to the industry. Some others are really active in the material development. There are a lot of challenges, especially around the nano imprint lithography, to find some materials that can be easily imprinted with good properties. And a lot of startups also try to have a central position with a more vertical business model and position themselves as a manufacturing platform to provide a one-stop service to the industry. So this position is quite attractive at the moment. Here are some recent news to show that the metasurface is a very active domain. So there is the acquisition of NILTI by Radiant Optoelectronics. So it has been announced a few months ago and eventually validated few weeks ago. There is also this investment in Lumotive. So the company raised $45 million. So this company works on active metasurfaces to perform beam steering. So the idea is to, for example, to perform a LiDAR beam steering without any mechanical moving parts. And it starts to work actually. And there is also the company related to the AR eyepieces, Celid, who raised $13 million a few weeks ago. Thanks for your attention. That's all for me. I hope this is a good introduction to the topic, and now I will take your question or let the next speakers present their work.